All right. Thank you, everybody, for joining. I see we got a good amount of people coming in, and we'll just have everybody come on in as they attend. So again, thank you for joining us. SEI Philadelphia here. Got a really good presentation today on the Delaware Memorial Bridge. It's UHPC for large deck rehab. So a lot of UHPC. I'm excited to see how much cubic yards were actually used for this project. Typically, most of this UHPC, we see little, joints and closure pores, but an entire overlay. I'm pretty excited to see that. So before we get started, I have some housekeeping for SEI Philadelphia. As you saw in the email, this meeting is being recorded, so just be aware of that. This is a town hall, so you do not have access to your microphone or a camera. It's already been disabled. But for the questions and answers, you do have that Q&A function. It's at the top of your screen. If you just hit the QA button, you'll see you can use that to type in your question. So as the presenters are speaking and question comes to your mind, feel free to use that right then and there. And at the end of the presentation, I'll go through and I'll read your questions out. And if you have any follow-ups, I believe you can just go back into that same question and ask any follow-ups or just create a new post. As you can see on the screen here is our QR code for our LinkedIn page. So take a second, scan the QR code, and follow us on LinkedIn. We do a lot of coordination, outside of email with LinkedIn, so you can see those posts. We also on the screen there, as you see our website, seiphilly.org, and if you have any questions, you want to email us, you can do so at phillysei@gmail.com. Oops. I just want to recognize our 25-26 board members here. If you've been on previous meetings, I introduced everybody, but again, my name's Mike Urban. I'm the chair for this year. And as you can see, our vice chair is Colin, treasurer is Greg, secretary is Alex, Nathan is our program director, and you get a lot of emails and correspondence from Justin. He's our director of public relations, and working with Justin is Kylie. And our past chair is Keith Merle. As always, thanks to our sponsors for our 2025 SEI golf outing. We raised a lot of money last year, and we are looking to continue that tradition and do that again in May of 26. So keep an eye out in the beginning of the year for flyers, for sponsorship opportunities, as well as signing up for the golf outing. It's a fun time. It's a great time to get out. See this group, and enjoy a good day of golfing, food, and drinks. I do have some good news for our chapter here locally. We were awarded an SEI Futures Fund. It's a small grant. It was $500. But that is being used to promote student and professional member interaction and obviously encourage growth within SCI, overall SCI and ASCE. And we are using this to take at the students coming out of school and then bringing them into the professional world. And for us locally at SEI Philadelphia, we're going to use that fund right there for our student event that we're going to hold and the winter of next year, the 26th, and with SEI being that main sponsor for that, and then we are also looking out for for you to help out. If your company has any T-shirts, swag, pencils, pens, anything like that you would like to donate, reach out to us, let us know, because when we do have that student event, it's your opportunity to get out, meet the students, or at least provide something, that has your company name on. And, these kids are coming out of school looking to get a job, and, it's just one step in the right direction for them. So anything you want to do to help, again, reach out to us, and, we'll get you guys on board. In addition to that, with the SEI Futures Fund, they are taking donations, and right now in December any donations that you or your company does provide, Thornton Tomasetti will be matching 1-to-1 up to $5,000. So this is, like it says right there, no administrative burden. This all goes straight to the fund. So that $500 that we did receive, any kind of donation that you give will go towards that for these students next year. So it's a great opportunity for you to help out. Remember when you were a student, you were looking for assistance coming out of school, and when you were in school, it's a great opportunity to help out. And again, think of the children. So that QR code right there will take you to that website. You can just go to asce.org, SEI Futures Fund, or click that QR code. It'll take you right there. Pass it along to your anybody within your company that can make that donation. Like I said, it's all, and if you have, and there's details on that website for the donations, for that. So please, if you can, feel free to donate. As for upcoming events, in January, we'll be having our next virtual meeting. We will let you know what that topic is. We're just ironing out those details, but we will have those shortly. February 19th, we will have our in-person joint meeting. I know we've been a lot of virtual meetings, but our next in-person will be a joint meeting with DVGI. We have a good presentation. So again, look out for those details. In February, we will also be having our second social. We had a good turnout for our fall social, so we'll be looking to build on that with our winter social. We will be sending out some a poll shortly to gather your thoughts on where we should be holding this. If we should, looking to go into Philly, stay in the King of Prussia, maybe somewhere along the main line to have this. So just wanted to get your feedback on where you're looking to have that. So keep an eye out on that. We'll probably put something on LinkedIn, or we'll probably put something out through our contact page via email. So, and then as I mentioned, we are having our SEI college event. It will be this winter. Most likely it will be held at one of our area colleges. We're just going to finalize those details. And once we find out, we'll be looking out for support from you guys from a professional standpoint, again, to help these students out and, begin to welcome them into our community, especially SEI, and start getting them out to events. And then, looking ahead, in March, we will have another virtual event. So as for today's presentation, we have two speakers with us. We have John McFadden. He's a project manager at UHPC Solutions. He has 25 years experience in the bridge and heavy highway construction management, and he oversees estimating, project startup, execution, and closeout for these UHPC projects. And obviously he's led numerous across the US, and he's a graduate of PACE. And then we also have Peter. He is a technical expert at UHPC with John over there. And he also has 25 years experience in anything concrete. So, he's ready to give us a lot of good information. He has degrees in civil from both University of Toronto and Queens, and an MBA at Wilfrid. And he is a licensed civil engineer in Ontario. So thank you for coming over, crossing the border here, and joining us. So at this time, I'm going to stop sharing, and I will hand the presentation over to you.
Great.
Yeah, thanks, Michael, and thanks everyone at SEI Philly for having us today and coming to join us, listen to our presentation on the Delaware Memorial Bridge. Give Peter a second here to get that queued up. All right. So again, I'm John McFadden, project manager with UHPC Solutions. Just to give you a quick background on who we are, so you know our perspective. We're a contractor. All right. Our UHPC Solutions business is a joint venture, which is based on two companies. One, Basilico, which some of you may have heard of. They're based out of New York, and have a presence in the whole Northeast here, and Texas and Florida. And then Wallow, who's coming over from Zurich, Switzerland, with their pretty large GC over there, and have vast experience with UHPC, dating back probably 15 years or more. They're using UHPC much more over in Europe. So that's who we are. We specialize in bridge overlays, field cast connections, and pretty much any other application of UHPC. That's the work that we chase all over the U.S. And we have the specialty equipment to do the work from anywhere in remote parts of the country to urban areas. We'll mix, transport, place, and install the UHPC for you on your bridge deck. Again, we're just a contractor, so we go out to the market for all commercially available UHPCs. We kind of evaluate each one, of course, take in their price quote for the project, and then we select the right one for each project. And we've worked with at least 9 DOTs. I think these numbers might be a little old. 6,200 yards is probably closer to 7,000 cubic yards installed in the U.S. at this point, especially after this DMB project. I'll let Peter take over and talk to you a little bit about UHPC.
All right, thanks, John. Okay, so talk about UHPC. I assume a lot of people know about it. Some know a little about it. Some know a lot about it. So just give the quick overview. What is UHPC? It's an ultra high performance concrete. It's an advanced cementitious based material. And generally what you have is, and I usually hand this out, but I have a little jar in here. It's a premix. Use that. It's where all the cementitious materials are in there. In the premix, you have silica fume, ground quartz, silica sand, and cement usually. So it's very fine particles, and you can see they're very loose and they work. It's very well optimized. This sample is over 10 years old. It's very fluffy still. So basically, you have the premix. You add super plasticizer, water, and fibers. Show those two again. Sorry, it's the last one. You can flip over to me. That's the fibers, and they're like little syringes. They're very fine. They kind of clump together, as you can see that. They're 1/2 inch length and 0.002 inches in diameter. So what that does is these materials are getting mixed together, and you have a very dense matrix and a very dense material with tensile properties. So as a fun fact too, if you compare that to a regular concrete with 3/4 inch stone, sand, and cement, and the number 4 rebar, if you would scale that diameter down from that number 4 rebar to the diameter of this fiber, you pretty much have the same aggregate size, which would be a 3/4 inch in regular concrete, as well as the finest particle in here, which would be a silica sand, which is around 500 to 600 microns. So it's a micro reinforced concrete, more or less. So it's a very dense, compact material. Due to its density, it's very durable. No salt increase, no chloride increase, no water increase. And because of that, you can get very high life cycle. Now, generally, the material is available in 2 types of different plastic stages. One is the self-consolidating mix, which you can see here at the top of the screen. It's a self-leveling, flowable material. It doesn't need any vibration. That's being mainly used, Mike was saying, like for joint fill applications, connecting precast elements. And then this other mix is it's a thixotropic or more semi-thixotropic material. So as you lift up the cone, you can see it stands up on its own, and it can hold its own slope. But as you add a little bit of vibration to it, it can form and place itself into the shape that you need it. So this is ideal for overlays, and a mix like that was used on DMB. Just generally, if you compare UHPC with regular concrete, you can get very high compressive strength, 17 to 35,000 PSI. 35, you do thermal treatment with that. Generally speaking, the cast in place materials, they're in the ranges of the 17 to 25 KSI. Again, you can sustain tensile strength. You have a very dense material. Most of them have, in the rapid chloride test, less than 100, generally in the 15 to 20 Coulomb range, and it's resistant to freeze thaw. So the material's actually been tested for quite some time too now, since '96. This is the U.S. Army Corps. They have a long-term marine exposure station up in Treat Island, Maine. In there, if you basically have on this wharf, you put a whole bunch of concrete samples, you get about 100 freeze-thaw cycles a year. If you put a non-air trained concrete in there, it's going to be deteriorated and gone within a year. So there have been samples out there now. And generally speaking, if you look at these samples after 20 years, you see chlorides penetrating the first quarter inch, and then it's dense. Nothing goes into the matrix. So making this material very durable. It also has a very great resistance against abrasion. This is an older slide, basically where you could take a regular concrete material that was exposed to marine environments, that's being hit by waves and water all the time. So you have a regular concrete over here, and then you have a UHPC material beside it. And you can see, like within 10 months, you already see the regular concrete starting to deteriorate, whereas the UHPC looks beautiful like on the first day. So what makes this material unique? Yes, ultra high strength, tensile capacity, it's durable, low porosity, excellent bond development. So if you take, for example, and you don't design with it, but tests have shown that a number 4 rebar and stick it in the UHPC and you pull at it and it's embedded for 3 inches, you pretty much break the bar every time. So it's very, very good for precast connections to design with that. Plastic properties are, you can adjust for the applications, and it's used in bridges, marine environments, dams, treatment plants, and airports. And just for an information here, we put that up there just recently. The ACI 239 committee does a lot of work. They're working, they just brought out a tech note really describing what is UHPC. This committee also is working right now on design guides too, as for materials, properties, as well as for designing with the material. So where is UHPC used in the US? So the first time was more or less in North America. It's been around since the late 90s, but in the US and bridge applications for joint fill applications, which you can see here, it's taking precast elements for accelerated bridge construction. That pretty much started back in 2009. A lot of states have taken on to it. It's a very unique, ideal application. You can design connections that are very efficient. You can basically, in the connection, it's the when you would test it, it's always, you can make very small connections, as you can see here. They're usually 4 to 6 inches wide. The rebars, they don't have to overlap because the UHPC can take all the strength in the connection. Here's a couple other applications. You can see precast box girders, and this is what I was talking about, that the rebars, they don't have to overlap. You can make very nice, efficient connections. Here's like the same thing, a saw cut between the precast deck panels, and here's the UHPC in there. It's very good for accelerated bridge construction. Now, overlays, that's started back in 2014. You can see that here in the top left. This is a bridge in Switzerland, Sion. It's a large viaduct. From there, it took a little while until the technology got rolled out into the US. It's been now more widely used. Basically, this is a project in Delaware. It was back done in 2019. Yeah, so and in the past, it was always just like simple one-span applications. And that's where DMB came in. Which was a scale up, and I'll shoot it back to John here.
Yeah, thanks, Peter. All right, so what we're all here to learn about today, the Delaware Memorial Bridge application. So just a couple quick facts. The bridge is owned by the Delaware River and Bay Authority, and this project was designed and inspection was performed by WSP. So we're talking about the northbound structure here, which in this photo is the one closest to us here. It's about a 2-mile long structure with 50,000 ADT, 4 lanes wide, totaling 51 feet, and it's about 550,000 square feet per bridge. If you're not familiar with it, most of you guys probably are. It's 295 between Delaware and New Jersey. Structure 1, the one that we're talking about today, was originally built in 1951. After structure 2 was constructed, they did a deck replacement. There was a barrier down the middle separating traffic that was removed, and there was a deck replacement done somewhere in the 80s as well. An LMC was put in, maybe 90s. I'm not sure exactly on that date, but obviously it was in disrepair. Had high chloride concentrations in the top 2 inches. And in 2018, the DRBA did a study and determined that a UHPC overlay would be the best path forward. You can go ahead to the next slide there. So this project, $71 million contract. I will preface that by saying, you know, the material is expensive, but it was also very expensive to do this in multiple phases, in a 24-hour operation with a alternate side a lane of traffic on the southbound structure. So each of the 3 phases had that lane pushed over there. But it was just about 5,000 cubic yards of UHPC. The design was for 2 inches of overlay. You get a little bit of amplitude, a little bit of overage, so the average was a little higher than the 2 inches. And this was done in 3 phases, starting in the fall of 22 and then spring and fall of 23. It avoided all the major holidays and all the heavy traffic of the summer rushes going out to the beaches. Totaled 9 months of construction, and we were to maintain at all times 3 lanes open in both directions. So we were able to do that with minimum traffic interruption, which was a great thing for the owner. They've got a toll on this bridge, so obviously that was a big concern for them. And it was a big time saver and cost-effective alternative to the full deck replacement. So I think they were pretty happy here. Going through the process, it starts off just like any other overlay. You start off with cold milling, take off as much of that initial bad overlay and patchwork and all that you can. Followed up by hydrodemolition process. You can see some of those photos down the middle. And on the right there, the rebar is exposed. Although it wasn't technically supposed to be exposed when you go down 2 inches, the rebar is just lower than 2 inches. You can see the deck between is a little higher, but that paste, there's no aggregate to hold it. That paste around the bars winds up coming off during the hydrodemolition process, which exposed a lot of that rebar. And it was kind of a good thing because we saw some corroded bars we were able to repair and put some replacement bars in along the way. So UHPC typically comes pre-mixed like Peter had in the little vial that you guys saw before. It'll come with the dry pre-mix, which has the sand, cement, and any other proprietary cementitious dry admixture. That's all in this bag. Comes from a blender into the bag, comes wrapped up and shipped out to your job site. So on this project, we elected 1 cubic yard super sacks. You can get them in different sizes, but that's what we used here. And you could just imagine that was a lot of room to have thousands of super sacks stored on site to be ready to mix on site. The fiber typically comes in 40-pound bags, but for this project, we moved up to a super sack of steel fibers. We've got water and admixture that all goes into the mix, and that was handled right on site in the batch plant. This batch plant was designed in conjunction with a company out west called Mixer Systems. They have a lot of these high shear mixers for different concrete mixing applications, and they've been pretty prevalent in the UHPC mixing industry. So we went to them. We designed something that specifically could be used in a single lane closure so that we could leave 3 lanes open for the DRBA at all times. 1 lane for the mixing operation, 1 lane to transport our buggies and dumpers past. You can kind of see in that picture on the right. The material would be transported up past the batch plant there, and any other construction operations could access through the work site without needing an additional lane closed, which was really important for us. You can kind of see quickly here, there's a big hopper. We would load all the pre-mix in there. And then as the the mixer, which is all the way over to the left side, as that would be empty. Then the premix would dump out onto the conveyor belt, run up the conveyor into the mixer. At the same time, the computer starts telling the water pumps to turn on and the admixture to go in. And after we get the UHPC starting to blend up nice, then this fiber doser here in the middle, that'll turn on and put the fiber up the conveyor as well. So each batch would take about 25 minutes. And you could see here a nice fresh batch of UHPC coming out. We batched 5 cubic yards at a time, and we had 2 of those batch plants set up on the project. We were pushing volumes of 120, 125 yards in a shift to go from one joint to the next joint and do a full overlay joint to joint. So we transported the UHPC from the batch plants in these big dumpers, we call them. They proved to be a little too large to dump right in front of the paver, so we transferred the material from the dumper into Georgia buggies, and then the Georgia buggies would come up and dump just in front of the paver. Now this paver is a Gameco product. Again, another piece of equipment specifically designed by us in conjunction with the manufacturer. And this is specific for UHPC, but is basically a modified slip form paver for thin UHPC applications. So it's got vibrating beams on the front and underneath to finish off, screed off and finish off the UHPC in place. And you can see these pictures on the left. And in the middle here, the UHPC out in front it's kind of maintained at a level out in front of the paver, slightly high, so that the material can be pushed along and pressed down and struck off. And this picture on the right is the finished product out the back of the paver. And you can kind of just see, if you can go back to that for one more sec, Peter, you can kind of see the curing operation following up behind. But one other fun fact about these 2 pictures, the left and the center, is we paved uphill and we paved downhill, which was the first time ever for UHPC on a bridge deck. So here, the curing operation, we typically in the past, UHPC was cured using a light application of curing compound followed up by polyethylene poly tarps. And those tarps had to be held in place over the top of the UHPC to hold all that moisture in, not that there's much to begin with. And what would happen, especially on a bridge like this, where there's always wind, is those tarps would flap up and down and they would pull out, or you'd have to weigh it down with so much that you would make impressions on the UHPC. And that was troublesome to get out during the grinding operations. So we pushed and we innovated. We tested a whole bunch of these curing compounds, and we found a nice heavy application of this one here. We're using actually paint sprayers to apply it, and it worked out even better than the plastic without any indents from the plastic. After curing is complete, typically 2 days to get your loading strength of, say, 12,000. I think it was 12,000 psi was what the requirement was in this project. You can go ahead and start on your grinding and grooving. This is typical, smoothness diamond grinding equipment. They do have to modify their operation slightly. We always recommend using the best blades that money can buy, and they run a little more water to make sure that they're flushing through the steel fibers that just kind of come out as part of that top sacrificial layer that's removed. But you can see here the nice corduroy finish, and the grooving gives it a nice texture. This was longitudinal grooved, as it was designed by DRBA and WSP.
All right, I'm back on deck.
There you go.
All right, thanks, John. So that's about the operational side. So I'm just going to talk a little bit about QC specs and for the project. So it was very unique for this project. There was a pre-qualification experience requirement to be able to bid the project, which was very important for the owner. You have to think about it. As I mentioned, the first projects, they were just like single span bridges. Now you're going to 2 mile long bridge. There's a lot of risk involved. So for this one, particularly the owners with the designers, WSP developed new specs, and they've been used in other DOTs now too. But for this one, it was very critical that the contractor needed to show prior some experience with UHPC, plus also they needed to have operators in grinding and grooving, and for the machine to operate on installing ultra high performance concrete. Then the other thing, pre-qualification is required. The supplier had to provide pre-testing to make sure that the material could meet the required strengths, the requirements for strength, which was 12 KSI after 2 days, 18 after 28 days, and they also had to provide direct tension testing, bond testing, modulus elasticity. So at the end of the day, the supplier has to provide a whole complete package showing that the material meets the specifications for the project. But on the job itself, the only QC that was done was then compressor strength testing. For every day we were producing or placing UHPC, and flow tests were done. The flow tests were done just to make sure that there's a consistency of the material, and that it's always visually, and that it's the same from batch to batch, which is very important for UHPC, because you want to have the consistent material in front of the paver. You don't want to have the paver to stop and go. It all has to work together like a symphony. As the material is being produced from the batch plant, delivered and placed in front of the paver, it has to be smooth. But also throughout the day, there's a lot of changes in temperature, humidity, light, sun, and we've seen that. So what we had is we were then working with the supplier to adjust the mix within the ranges to ensure that the hardened properties are met. Therefore, the flow test was very important to validate this. The other thing we had to do for this project specifically, because it was the first time now of this large scale, we as the contractor had requirements to the supplier. We needed them to make sure we can get 12 KSI in 2 days, to 28 days, get the 18 KSI, but also we required from them 1 hour working time. The reason being is, as you saw, the batch plant is at the bottom of the bridge, and we had to move the material all the way across in these dumpers. It takes about 20 minutes to drive across there. So you basically have material sitting in the dumper that's not being agitated. So it was very important for us, by the time it gets over there, you place it in front of the paver, that it's still workable. And then it can sustain all these changes, as I said, wind, low humidity, cold, heat, and if it's a hot day, that we don't need to cool it. So and for this project also, we had to withstand a 6% slope while traffic goes beside on the main road. So we'd actually, before they awarded the contract to the supplier, we did trials in our yard with various suppliers, and to see what kind of behaviors and what kind of material will work best for us. And in the end, we kind of decided that the ductile overlay 3rd generation formulation worked best for us. The project also required mock-ups. Here we're just showing the 2 mock-ups. One of them is done at the below the bridge, and basically we're required to simulate that we can meet the 4.5% slope, but actually we did set it up for 6% just to make sure that the material can hold in place. This is very important that we're trying to tell other owners and designers. Mock-ups is very critical, because still there's not a lot of contractors out there that have a lot of experience, and always use the equipment. And like, as you can see here, this was a paver that was being used on the bridge. Use the equipment in the mock-up that you're planning to use on the project. We also had to do a second mock-up that was done, you can see here, on top of the bridge, because there was a lot of concern if it's very windy, sunny, the slope, is the material going to flow from the vibration? Because even though there's a speed limit posted, you guys all know when you go down the bridge that those trucks, they still fly at 70, 80 miles an hour, and there's a lot of vibration while you're paving. So to show that the material can hold the slope. And yeah, so then I answer your question too, Mike, is the yes for this one. We could easily do the slope of 6%. We're actually doing a project right now, which is also in Delaware on I-95 in Newcastle. That actually has a 7% cross slope, which is a very challenging, has never been done before. But also for that project, we're successful to pay for the 7% cross slope. We're cautioning the industry. Not everybody can do it. Not every material works. Not every equipment works. But for this one, we felt comfortable to do it, and we were able to do it. Then there's the QC inspection. So for every batch that was done, the material was dumped into these dumpers. They drove up to the QC station where young Jack took a scoop and he did the flow test. We also recorded for each batch the static, the dynamic flows, temperatures of the mix, the timing, and what material was used from which bag. So we had a detailed understanding where the material was placed on the bridge. Now this is quite something too. So what happened actually, because we had initially smaller batch sizes, we started with 2 yards per batch, then 4, and then 5. So you actually can see, and this may be another number, it's quite interesting. Overall for this project, we did 4,924 cubic yards, which is a lot of UHPC. If you take that, if you look at that, this is generally how much maybe the entire North American UHPC industry uses in 1 year for joint fills, precast, girders, all that's out there, and this one project used that much. But also we did like almost 1,500 flow tests. So kept Jack pretty busy. Then the same thing, we did cylinder testing. We did the 3x6 cylinders. We always had the daily batch, and we had them in the bathtub, so they're protected from the wind, but still has the ambient conditions. And we did 2-day tests, 7 and 28. Pinoni up in Prussia did that for us. And we also used thermocouples. Thermocouples work really well, particularly if you want to understand what the strength gain is, because after 2 days, when you want to get on, you want to have your 12 KSI. So UHPC material works very well with thermocouples because it's very consistent. It has a lot of very consistent materials. So having the slope with that and understanding the initial strength gain was very crucial for us as well to see when we can put loads onto the deck. All right, John, I'll give it back to you.
Yeah, so something that we like to kind of brag a little bit about here is the smoothness we were able to achieve on this project. Now, again, this is at a 4% longitudinal slope and 2% cross slope with traffic moving, on the same structure, just adjacent to us. So definitely challenging. Well, we found that from phase 1 to 2 to 3, we made improvements all the way through. And our best rideability came when we overfilled by 3/8 of an inch, a little bit more than the typical recommendation. And we did the grinding in 2 passes. Some of these profiling machines kind of work off of averaging out the bumps that are there. And when you do a quick pass, not trying to take a lot off the top, you're able to take off some of the little small undulations, and then the next pass takes your 1/4 inch production removal off. And we wound up at IRIs. I mean, this is phase 3. This is as low as 22 of an IRI. Everything lower than 65, which is an incredibly smooth ride. So if you do drive across this bridge going northbound and you ride in the 2 right lanes, you'll find that it's a very, very smooth ride for you. Challenges and successes. There was plenty of them here, plenty to learn on this project. The scale of the project and the rapid timing, small work windows, with the work seasons, needing to get everything 100% completed during that time, and all the different steps of the operations, proved challenging. You have barrier across the whole structure. You only access in from one end or the other. So you try to sequence the operations so that you can get work crews to where they need to go and continue the operations ahead, the demolition, the prep work, the cleaning. formwork and placing of UHPC, the curing of it. And now that section where the UHPC is cured, you can't pass at all. And the pavers across the bridge. So then on the backside, you have to get it, ground, cleaned up. We had to do joint installations at all the expansion and relief joints on the bridge. And, just the size of it and the scope of it was a huge logistical challenge. Again, we were working 24 hours, 7 days a week. We had meetings day and night to coordinate all our operations. We had up to 200 people working on the job site at a time. It was a big undertaking. The weather impacts, the open gutter on the bridge, they were all significant challenges of how to overcome hydrodemolition procedures, capturing of water, lots of little things that on a small overpass are just kind of overlooked. On a big structure like this, even if it's a small thing on a small overpass, well, you magnify it by 2 miles long and it becomes a huge issue. Some successes, we completed the work on time with a very high quality. We maintained 3 lanes of traffic in both directions at all times, other than when we put the barrier out, of course. We did paving records of 124 cubic yards in 6.5 hours, very smooth operations. Really got our guys trained and everybody kind of bought into the overall scheme between the carpenters and the demolition teams and the guys finishing concrete. It really worked out great. Placing the overlay with the heavy slope and no speed limit reductions, no issues due to vibrations, which just a couple of years earlier wouldn't have been possible. And then I don't think we have any slides on it, but there was a truck fire on this bridge right on top of the UHPC that we'd put in on a previous phase. So we wound up having to go in and do an emergency repair. The emergency repair was done by a milling operation and then just a small application of UHPC with a small screed. And then we went back the following season and removed that entire section from joint to joint using hydrodemolition and replacing that entire overlay through there. So we found that small repairs can be done more easily than we thought. Larger removals and reapplications can be done way more easily than we thought. So it was a great learning process and understanding what can be done. What did I miss there, Peter?
We got it. Just flipping the switch.
Yeah. So in conclusion, we've got to give credit to the DRBA. They took a significant risk being an owner to really put forward a UHPC overlay project of this size where it hadn't been done here in the U.S. and entrusting us as a contractor to perform that work. They had developed new specifications that kind of progressed the ability of us as a contractor to be able to install the UHPC accurately, without a whole lot of risk and to be able to understand that we'll get paid properly. So it was kind of a win-win that the owner doesn't have to carry a whole bunch of extra costs for our risk. The material supplier developed a material that really worked well in the existing conditions on the bridge, with the workability that was required, with the distance that we had to travel from the batch plant to the placement area, holding the slope, not moving with vibrations. It was a significant development by them. And us as the contractor, we developed innovative construction methods. Some of it was simple as the curing methods, the grinding and grooving methods. The batch plant was a significant undertaking to build those batch plants, and just scale everything up. Something as simple as getting water up to the bridge deck. When you're talking about a rise of over 200 feet from the yard below where we were able to store and hold and pump our water from and push that water 2 miles across the bridge. Well, that was a engineering feat on its own, with the volumes of water needed for hydrodemolition. That's no small feat. And the same capturing that hydrodemolition water, pumping it back down, treating it on site, disposing it on site into the local stream, and doing all that, accurately and appropriately was a significant achievement. So the final conclusion is a properly installed UHPC overlay can be done on large scale projects and large bridges, and provides owners with a durable, long lasting bridge deck.
So yeah, so before we wrap it up, a couple other quick things there is we're just thinking, as you guys in Philly, there's a lot of big structures, large structures. Don't be scared. That's kind of the message that we have here. UHPC overlays for large structures work really, really well. Why? Because if you have a large structure, you have to do already your maintenance of traffic. So that's costing a lot. It doesn't matter what material you put on. Plus, it has now been proving that it can be installed rapidly. It gives you a very smooth ride. And it is a very long, durable solution. Yes, we're saying extended service life of 75 years plus. In my heart, I know it's longer, because at the end of the day, there's been done tests now with that extrapolated out for 300 years, but no engineer wants to say that. But for these kind of projects, and particularly for these large scale structures, if the substructure, or if you just have a deterioration in the top 2 inches, and the rest of the deck is really good, similar like on DMB, they're not anticipating to touch this deck for a very, very, very long time. And that's where UHPC overlays make a lot of sense. If it's very deteriorated and you turn on the hydro demolition, you shoot right through all the time, it's probably not the right solution. But if you have a large structure with a similar setup, it makes a lot of sense and it works very well. Also, a couple of reference materials, but just want to put that out. You can see here the link. The FHWA has done all the work. This is particularly for overlays if you're planning to design and work with it more. They have now brought in a tech note on the experiences from the early implementations. Talks a lot, also similar from this project, what they have learned. They came out, FHWA came out on the job site when we were there. They took a lot of key learnings from there and many other projects to make this available for the various DOTs and the design community. Plus also now there's also other materials here that talks about the design construction of UHPC, bridge preservation and repair solutions. There's other ones in there, and that talks about the life cycle cost analysis as well. And then this is the very exciting part. There is now a design guide for UHPC. The one on the left here, this is the FHWA version. That's for free. You can download it. If you need the AASHTO version, you have to buy it. It's the first edition here on the right. My understanding, there's not a lot of difference between the two of them. But if you want to design with UHPC, here's some excellent material for you to look after. All right, that kind of concludes it for us. And I saw a few questions came in. We can tackle a few of them right away, but also we're happy to answer some of the other questions. I grab a couple quick there, John, that I already saw. One is the testing samples based on batch volume or on volume or batch. For this project was decided the flow test was done on every batch and the compression tests on every daily production. So if we did 50 yards that day, you did it for 50. If you did 200 that day, it was done for 200. That was done for this project. Most of the projects are similar like that. And then the other question that was here is, does the steel fibers tend to rust over time? So the steel fiber always rusts. It's a regular steel, but what's happening is it only rusts on the surface because you kind of a little bit of a freckling look, but it breaks off right at the surface. So even here, if you have the UHPC overlay, within one season, all the fibers that are exposed, they break off. You can take right now your smooth hand across it. You don't cut yourself. You don't hurt yourself. It's probably after a year or two, but it's just on the surface. The rust doesn't go penetrate because the matrix is so tight. There's no oxygen, no water, chlorides that go in there. Okay, any other questions? Did I miss?
Yeah,
There's
we
another
have
one.
one here. Anticipated, I guess there's two of them. Anticipated life of the overlay. Do you anticipate that the next project on this deck would be to replace the UHPC overlay or just fully replace the deck?
I don't see the UHPC overlay to be replaced. To be honest, no.
Yeah, I mean,
Go ahead, John.
I think that the life expectancy is still a little bit of a question mark because none of these applications have actually been in for 75 years or anywhere close to that long. But that is the anticipation based on some testing, and there is a test that's been performed at the Rutgers Beast facility, and there'll be some documentation coming out soon regarding that study, which simulated 30 years of our UHPC installation versus a LMC installation. So that'll be some good data to come. I think the substrate of that deck and the rebar and everything is still in very good shape. If they needed to replace the UHPC in 75 years, it all needs to be evaluated again. The whole purpose of UHPC is an armor, but also a waterproofing. So it strengthens and proofs, waterproofs that deck. So there really shouldn't be any, infiltration of chlorides to that substrate during the life of the UHPC. I guess towards the end, don't know exactly what it would look like, but you probably could just replace it with another overlay.
And just to add to that, the difference between the UHPC overlay and other overlays are UHPC overlays contain fibers. Okay, so there's two things. The matrix itself is very tight, that has no pores that are connected, so no chlorides can penetrate. Now the next thing is, as we all know, in bridges, they move, they flex, they expand, contract. There's a lot of things going on, and generally if a crack forms, chlorides keep penetrating. Here, what's different, because it's fiber reinforced, the fibers bridge the crack, and you have a whole bunch of micro cracks that you can't see with the naked eye. Therefore, it's not impermeable. That's different with other overlay materials. They don't have the fibers, so if the crack forms, it just goes in there and penetrates.
Okay, I have another question here is what would be estimated cost for the full deck replacement using conventional concrete with the same MPT? I don't know if you knew that from, if WSP had already looked at it, if you had that kind of information.
I don't remember the exact number. I do know that somebody kind of leaked what they thought in their study, and it was something to the terms of twice that cost.
Twice.
Yeah, I think it was more than that. But I think the bigger impact for them was the long outages of lanes affecting their tolls too, right? It's a huge toll income that they get on these bridges, and traffic backs up. Even with the 3 lanes open, traffic going northbound backs up significantly during peak hours during the week. We were seeing some of that even with the 3 lanes open, and that wasn't even during the holiday season and the summer season. So you would need to stretch through all those seasons to do a full deck replacement, and it was just something that was just out of the question for the DRBA. So it wasn't only just cost, which was a significant difference, but it was also the effect of traffic and where that would have pushed the traffic up the line to the next bridge and away from their tolls and all that.
And with this work, like in the end, we had 9 months of road closure, right, John? That was it, totally.
Yeah.
So during those 9 months, you lost 1 lane in each direction. So that was huge for the DRBA, rather than have the whole bridge closed and you losing one direction completely.
Yeah.
Great. I have another one here. What is the best method to remove UHPC from the top of a beam without disturbing the beam? And does it require specialized drilling tools that most contractors don't have?
Yeah, so really, I think if you're talking like a joint fill that you're trying to remove or something like that, the best way to remove that is with hydrodemolition, without a doubt. It is a high strength, high tensile concrete, which doesn't fracture apart like typical concrete does with hole rams or chipping guns, stuff like that. So the hydro demolition process works much better than any kind of chipping operation could. And that of course would leave your rebar and your steel framework all untouched, as the hydro demolition process would leave it nice and clean with all the UHPC removed. If that answers what you're talking about, what you're trying to ask there.
If anybody has any more questions, use the Q&A. I actually do have 2 questions. I believe the last time I was working with UHPC, I had a contractor say it was very difficult to clean. Is that still the case?
Yeah, cleaning up in general is an ongoing operation. We always are, we're always careful to tell our crews not to use their hand to wipe off shovels or rakes or their boots or anything like that. And as it gets on your equipment, like the Georgia buggies throughout the day and the chutes of the batch plants, it is a constant cleaning operation as it kind of cakes up. It's very thick and kind of tacky. And it'll cake up, and then the steel fibers, grab more of it as that day would go on. So you want to clean everything, use a little trowel or a shovel or something, some kind of tool to clean your equipment, throughout the day. Our big batch plants, on the days that we did 124 yards, those were long days. Throughout all those hours, we had wash systems built in, and we could run a wash and wash down the interior of that mixer right in the middle of the day, just to kind of clean and get some of that gunked and caked up material out of the mixer.
Yep. And then another question, and maybe it's in the manuals that you shared at the end, but have you ever used it on any other kind of, I would say, patching applications? Say, like, you did show the one picture of, you had it right there on the shoreline, but say like a pier nose or something where you get these substructures that are deteriorating. Has it ever been used as like a patching application?
Yeah, Peter, you can add in if you think of any others, but I know for sure Virginia DOT is using it for all kinds of repairs, specifically like abutment or header repairs with their emergency crews, even their maintenance crews. It's been used. What we've seen mostly, it's used as abutments or headers on a job where we're already doing the overlay, or we're doing joint fill or connections. But it's been used on abutment faces. We did a project up in Connecticut where it was used to repair the face of an abutment. I know there's been other applications, but we haven't been so involved in them. Pier protection, stuff like that.
Girder ends.
Yeah, a lot of girder end repairs where
link slabs. That's in New York. They do a lot of link slabs. It really depends. I mean, but it doesn't mean you can't try.
Yeah.
Sounds good. All right. Well, we're just about at the end, so I'm actually gonna, and if anybody has, you can see their contact information there. So if anybody had any questions, please reach out to John and Peter. I'm going to share my screen now and take over. So on behalf of SEI, Peter and John, thank you very much. Because you took time out of your day, you will receive your a fancy SEI Philly Yeti coffee mug here from us.
That's awesome. Thank you.
Yep.
We'll be in the area. We can pick it up one day.
No problem. Yep. I'll be reaching out to you to get your addresses for that. And then as for the PDH, we do have the QR code right there. If you can scan that in. You can get your QR code, and you can also, Kylie just posted a link in the Q&A. So if you don't have a phone available, you can go to the link right there that Kylie had just posted to get your PDH certificate. So again, great presentation. I learned a lot. I hope everybody on the call here enjoyed it. And again, thank you very much for your presentation.
Thanks for having us.
Yes, thank you.
And thank you everybody else that's on the call. And that'll conclude the session. So thanks again.